PIB-CVD is a groundbreaking technology because because of its wide range of tunability and scalability. You can do very large area coatings, and also because the fact that maintenance requirements are very low. Yes, based on the Denton's linear ion source, which is a single gridded inductively coupled plasma source. The main features of the source are that the ion current density and the ion energy can be independently controlled without the need for substrate biasing, and also without the need for having additional grids. The precursors are delivered outside the source and in front of the substrate, so there is no frequent need for maintenance. So for comparison, normally the CVD processes run at very high temperatures like 800 to 1000 degrees centigrade. And if you take, for example, the plasma enhanced CVD, those can run at lower temperatures like 400, but they still require substrate biasing. In the case of PIB-CVD, all the energy for the CVD reaction comes from the plasma ion beam itself, and so there is no need for substrate biasing or heating. So this actually enables CVD deposition on plastic substrates, and you could do very large area coatings like in roll-to-roll web coatings. So multi-layer and gradient coatings can be produced in a single chamber using a single source, and coatings can be applied both on flat substrates as well as on high aspect BS. Because of the wide range of tunability of both the ion energy and the ion flux, you can actually use a single precursor like HMDSO, for example, and you can get a variety of films like from polymer-like to SiO2-like or even DLC-like films. On the other hand, if you were to use PE-CVD to do this, you would probably require maybe 3 different precursors, and so that would increase the level of complexity and cost. The PIB-CVD source can be integrated onto the Denton's Phoenix platform. The Phoenix platform is actually a modular inline system that can be configured for high throughput with multiple sources and a dual load lock, or it could be also configured as an R&D system with a single source and a single load lock. For low volume, such as in a contract coating house, you could configure it as an R&D, a small-scale R&D system with multiple precursor delivery options for maximum flexibility. In high-volume production with a single application, the Phoenix can be extended with multiple sources in order to achieve the desired throughput. The application space for this source is extremely large because of the wide range of tunability of its ion energy and ion current density. The only limitation here is the amount of CVD precursors that are commercially available. And in fact, in combination with source gases such as nitrogen and oxygen, you could do a wide variety of films even with a single precursor. And the other thing is it's extremely suited for heat-sensitive substrates such as plastics, and the other key benefit is that you could do graded coatings, coatings with graded properties. A large number of applications have already been explored. For example, we have done hydrophobic DLN coatings for architectural glass, hydrophobic fluoropolymer coatings for mold release, and we've also done hydrophilic surface treatments, and some moisture barrier coatings, protective coatings, and also abrasion resistant coatings. It can be used, for example, in the automotive industry to improve the durability of plastics. So we can coat a hard abrasion resistant layer directly on plastics such as polycarbonate or acrylic by transitioning the properties of the film from polymer-like to a glass-like film if we need high optical transparency, or DLC-like if we need high hardness and maybe other properties like low friction, etc. The other applications that we are investigating include moisture barrier films for protective coatings and OLED encapsulation and large area optical coatings for example, at the anti-reflective coatings for various end markets.